Okay, so I just wanted to take a look at one more example. We did one that started with a graph of a function, and then we did one that started with the equation of a function, which we turned into a graph. And of course, the other main way that we represent functions are with a table. So this is number 12, which is similar to some of your homework problems. And also gets back to that connection between area and distance, because this particular data set is time and velocity. So you can do this without thinking of it graphically, but it's always helpful to me to sort of have a little bit of a graphical idea of what's going on. So I like to maybe just draw the points out a little bit. And so let's get a little bit of a graph going here. And we've got points. Let's see, at time 0, this motorcycle is going like 30. So I'll just make this a 30. And that's at time 0. And at time 12, it's going a little bit slower. It's going 28. So make that 28. And then at time 24, so going in 12-second intervals here. It's going a little bit slower still at 25. I'm not going to draw the whole set because I think this will be enough to give us an idea. But part A then says estimate the distance traveled by using the velocity as the beginning of each time interval. So the first time interval is from 0 to 12 seconds. And if we're going to use the velocity at the beginning, we're going to assume for those first 12 seconds that it's going 30 feet per second. So we'll sort of assume the velocity has been that the whole time. And if we want to think of that as a rectangle, we can think of that as a 12 by 30 rectangle. So if it's spending 12 seconds going 30 feet per second, that'd be 12 seconds at 30 feet per second, which makes 360 feet. And over the next 12 seconds, we're going to use the velocity at the beginning of the time interval again. So we'll assume it spends the next 12 seconds going 28 miles per hour, feet per second. So again, that matches the area of this rectangle, but the calculation is just spends 12 seconds going 28 feet per second. So that would be 336, I believe. We can keep going with that. The next 12 seconds, we'll assume it's going 25. We can keep going. So you could do all of those for the beginning of the time intervals. And part B says give another estimate using the velocities at the end of the time periods. So we could also go back and say over this first 12 seconds, rather than assuming those 12 seconds he's going 30. We could assume he's going 28 instead. So for part B, we would make this assumption. And we'd figure out the area of this and say over the first 12 seconds, we're now going to assume he's only going 28. So now over the first 12 seconds, we'll say 12 times 28, which is hopefully 336. And then from the next 12 seconds, we'll assume he's going 25. And we'll look at that rectangle, that distance calculation. We keep going with that one. So we should be able to then figure out that part C, this green estimate that I made, is probably an overestimate because it's not going 30 the whole time. It's slowing down, right? The actual speed graph probably looks something like this. It's hitting these points. So the green is a little too much and the blue is not quite enough.